Hi everyone, my name is Finn Albertsen and I am currently a master's student in Maritime Management at the University of South-Eastern Norway. I found a very nice article which I would like to share with you. It was published in 2023 by those two authors below, and it carries the title "The Use of the K-Sim Polaris Simulator in the Process of Automatic Assessment of Navigator Competence." So what is the background? The background is that maritime traffic is getting more and more complex. We have larger vessel sizes, and also the total amount of vessels at sea, especially in global trade, is increasing. Currently we have more than 100,000 of commercial vessels sailing in our oceans, and a lot of accidents happen. I think we can also agree that the accidents in the past have decreased. However, human error is related to 80 to 85% of all accidents. Some scholars agree on the term human error, some don't. I personally don't. I think we should imply a more systematic perspective when we talk about incident investigation. However, there is no doubt that the human element is responsible for a majority of accidents. So with this in mind, we move over to the STCW requirements, which also underline that simulator training, which is a good option in order to prepare nautical officers for the commercial operation at sea, need to follow certain standards. However, there is room for interpretation in these rules. The main problem in the simulator training is that the assessment is quite subjective and it fully depends on the instructor. Now, what is the solution? The solution shall be an analytical and criterion-based assessment. What are the characteristics of such a solution? The results need to be comparable. Specific skills of the students are tested. The assessment is made easy and fast. The possibility to show results in different layouts and forms need to be there. And what I said before, the lack of psychological aspects influencing the assessment and personal bias should be erased. So such an option of personal bias should not be there. All trainees are treated in the same way, with strictly defined and prescribed conditions and limitations. Before we proceed into the study, I would like to continue with a few definitions. What is a simulation? A simulation is a realistic, real-time imitation of any ship operation, radar, navigation, propulsion, loading, unloading, and ballasting. What is assessment? Assessment describes the process of gathering information, making judgments about the information, and making decisions. Very important that we also know what a criterion is. A criterion is a standard, a mark variable, property, or point of view that makes it possible to distinguish something from something else. This we have to keep in mind for further discussions. Now comes the question, what is the research actually about? The objective of the research is to verify the usefulness of a full mission navigation bridge simulator in the process of automatic evaluation of anti-collision actions executed by the navigator. And the two authors, they are working at the Maritime University in Szczecin. They follow the following approach. They did a literature review on automatic performance assessment in simulator training. In a second step, they followed simulations with students, deck officers, and masters. So we see navigators on different experience levels. And lastly, they had an expert research with a group of nautical professionals. On this slide, we see the properties and details of the various ship models which can be operated in the Maritime University simulator in Szczecin. They have 22, and they have 4 bridges for the students available, which we see on the next slide. Here is a layout of the bridge design in Szczecin. Alpha, Bravo, Delta, and Charlie, 4 bridges. In the middle there's a meeting and debriefing room, and on the left corner we can see the instructor station So he has two screens which can be projected in the same way as the bridges are, and tools of communication, and also the actor's perspective here. And down below, basically in the center of the slide, we have an overview about the bridge layout, the bridge design from a student perspective. So each of these 4 bridges have this design. Okay, so now we are approaching the core of the research. Now we talk about how the automatic evaluation process works. Technically, it's divided into 4 different tasks. Task number 1, very simple. It's the creation of exercises, so setting up the simulator, choosing the ship models, and also deciding about the environmental conditions, as well as the simulation challenges, for example, an anti-collision situation that will come up. Secondly, we choose criteria that match our scenario. Thirdly, we have to verify the criteria to objectify the assessment. Also important here is, but we will also talk about it later, to define certain benchmark values so that the automatic evaluation process can work. Lastly, the trainee is assigned to a bridge and is processing the simulation. So what are we actually talking about here? Kongsberg Maritime, who is the developer of this simulator and the software, they have developed an application or an add-on which is called the Simulation Exercise Assessment. Very important is, that's why I also talked about the criteria, that the performance of the trainee can only be assessed if the criteria are defined well in advance and when we have benchmark values. But I will explain it further now. So this slide covers the setup process of the simulator. I think we can move on a bit because I have explained it in the previous slide, what it takes to set up the simulator. So before we dive into the different criteria, just a quick wrap up of what the automatic assessment criteria shall be based on. On the one side, there is no doubt that the instructor shall be experienced. In best possible cases, an instructor has a long experience at sea, followed by quite extensive experience in teaching, as well as simulator knowledge. Setting up a simulation is tricky because it is hard to define actual benchmark values for the criteria. In best possible case, we have senior nautical officers or masters, so let's say navigators with a long experience performing the simulation, which will provide the best possible way, or let's say a near perfect way of solving this challenge. And this knowledge can be taken into account when defining the criteria and the parameters. Of course, also previous students' reports and analysis in exactly this type of simulation can be taken into account, as well as current regulations by international institutions and existing examination and training criteria in general. Okay guys, finally the criteria are inside. So the Kongsberg Simulator Exercise Assessment, which I have introduced before as an add-on from the Kongsberg simulation, allows the instructor to choose between 57 different criteria. And the authors of this study have decided to group them in different categories. I will not read all of them because I think it's quite extensive and it's not so expedient if I just read all of them. If you would like to find out the details, you can just pause the presentation. Otherwise, I'm introducing the different categories now. So the first category of criteria describes anti-collision. Here we have parameters describing the CPA, the TCPA, a relative bearing to different targets. The second group of criteria describes maintaining established route. So here we have criteria that evaluate how good are the students in maintaining a pre-planned route. This can be, for example, the distance or boundaries of a track sector that we have defined when planning the route, and how the ship's position is relative to this sector. Next, we have radar and ARPA use criteria. So these are related to the setup of the radar. It can be, for example, the visible range and also the radar tuning. Next category describes the ship's movement and equipment setting criteria. So here we monitor parameters like the speed over ground, the speed through water, as well as the RPM order. Next criteria, group number 5, is related to a main engine and the power supply. Here we are talking about the engine power and the start air pressure. And lastly, we have a group related to emergency management, especially in terms of piracy and search and rescue operations. And these are very specific criteria. For example, if the students have used certain illumination during the search and rescue operation, or in terms of a piracy attack, if they have started gunshots. Okay guys, on the right side we see the layout of the simulation scenario which was used in this research. We have our own ship's position quite centered in this screenshot, with the red vector going in northwesterly direction. There are a lot of targets around our own ship's position. So we have one target which is in a head-on situation with us. We have one target, MV Antares, approaching from the port side. On our starboard quarter, we have MV Monrovia as a following vessel, and we have two vessels approaching from starboard side, MV Spring and MV Lake Ontario. So basically the idea of the outsource is here to provide the students with an anti-collision situation, and also the criteria which I introduced before were chosen in that category. Additional to the targets which are around our own ship, the simulation is confronted with reduced visibility, 0.5 nautical miles, and moderate wind, 15 knots in a direction of 270 degrees, 1 meter of wave height, which I think is not very special. And the participants were given the radar task to set up the radar, acquire targets using ARPA, assess the situation, plan and execute the anti-collision maneuver, as well as plan and execute a returning maneuver. The SEA is based on predefined criteria. The criteria, as I said, are the ones which have been introduced in the category of anti-collision before. All right, so on this slide we see for the first time how the performance evaluation is actually being done. The simulator exercise assessment add-on from Kongsberg provides the performance assessment in such kind of view. So we see on the left side there is a list of possible criteria to be utilized in this simulation, and next to that there's a column which allows the instructor to select different variables. In the center part we see the benchmark values. So on the one side the instructor can, for example, choose minimum distance to target 1 should be at least 1 nautical mile. So he will enter here 1,852 meters. There's also an opportunity when it comes to monitoring a predefined track by the students to define a sector in which the vessel should be maintained during the simulation. So different kinds of benchmark values are possible here, a minimum value or let's say an in-between value. And on the right side we see the actual values, the actual recorded parameters, and if there's a violation or a deviation from the benchmark values, this will result in some form of penalty points. or let's say counter values, which we see on the right side. So we have, for example, one counter value in variable number 1. While I studied this sheet quite in detail, I realized that this is not an actual performance evaluation sheet of this simulation. However, it was integrated in the article, but in my opinion, the chosen parameter do not match with the simulation exercise, and also that the benchmark values, so the parameters, are not really properly set up. If we, for example, have a look on this variable number 1, the distance to another target P1 should be minimum 25,000 meters according to the instructor here. In reality, it doesn't make any sense. So in my opinion, this is just an example sheet, but does not reflect the actual performance of this simulation which was done in the research. Anyways, we move ahead now and have a look on the actual results of this simulation and the performance assessment from SEA and Kongsberg. We see that the 4 bridges, Alpha, Bravo, Charlie and Delta, they have decided for similar approaches. However, the execution between these bridges was quite different. Alpha and Bravo have received the highest rating by SEA because their maneuver was very clear. That means they have initiated course alterations relatively early in the simulation, so they stayed most clear of all other targets. Charlie and Delta performed poorly due to incorrect handling of collision risks. So here the criticism is that the course alterations were not very clear, and it was not very confident that the minimum CPA and minimum distances to the other targets were maintained at all time. So due to this, the failure points have been collected by Charlie and Delta. So it's very interesting what the authors have done here. They have compared the automatic assessment of performance by Kongsberg simulator with the assessment of the same simulation by nautical experts. On the right side, for comparison, we still see the SEA assessment, which I just mentioned. Bridge Alpha has received the highest score with 4.5, followed by Bravo with 3.4. And on the last spots are Charlie and Delta, which have received only 2.0 points. The authors have invited various nautical experts with different experience levels. In total, 13 officers and masters were available, and they have consulted with 6 captains and 3 chief mates, 2 second officers and 2 third officers. So what do the experts say? The experts actually have a different opinion on the performance compared to SEA. Instead of ranking Bridge Alpha with the highest score, they have executed an average of 4.4 on Bridge Bravo, which received the highest average in the subjective performance assessment. The average grading of Bridge Alpha is 4.0. So here the ranking of position number 1 and 2 are opposite to the SEA assessment. But very important to note down is here that Bridge Alpha still has received the highest scores, the highest number of score 5 by the subjective assessment. So in total, and I've marked this down in handwriting, in total 8 times score 5 has been given by the experts, while the Bridge Bravo has received only 6. And this leads to the conclusion that yes, the subjective performance is still very valid. However, there is personal bias and personal preferences, also in terms of efficient ship handling, definitely come into play. And the SEA objective assessment is already in this small reference group much better than the subjective performance assessment. Coming to the conclusion, yes, automatic assessment systems like SEA will play an important role in the future of simulator training, and it is very necessary that the industry is improving here, because the training performance assessment is purely subjective at this point in time. Human expertise will remain important, but systems like SEA can provide a structured, reliable assessment only if parameters are properly selected and the limits are correctly set and weighted. The authors had two different criticism. One was that currently it's only possible to allow 50 conditions to be monitored by SEA. That does not mean 50 parameters at the same time, but 50 conditions. For example, the distance to one target at one point of time and the distance to the same target at a second point of time in the simulation is already 2 conditions. Lastly, the number of available criteria, at the moment it's 57, should be extended, and there should also be a possibility for the customization of own criteria with own parameters and weighting in the performance assessment. Yeah, this marks the end of my presentation. I would like to thank you very much for your attention, and I hope you found it interesting. Thank you so much.